and consider this set. Okay. So it's a collection of the omegas for which the map that takes into F and maps it onto the W plus omega, okay, which has derivative. So it's a collection of the omegas for which a path of the Brownian motion, okay, at an instant, it's a collection of those omegas for which at an instant s, the path of the Brownian motion has derivative. So I'm going to show
Is the measurable?
That's what I'm going to show. And how I'm going to show? T that back and derivative with respect to time. Is differentiable with respect to differentiable with respect to. So I'm going to show that this guy has measures here. So for that, I'm going to show that this guy is a subset of collection of very interesting kind of sets which has measure 0. Okay? So it's dominated by such kind of sets. So if those sets which are dominating this A has measure 0, then this has measure 0. Okay. Now, if maybe a rough general one, if a function which function and derivative and t to this function, then what you can say about this quantity, this w of t plus epsilon minus w of t and w of t. What you can say about such quantity? That if divided by epsilon. Yes. What you can say about such a quantity? That this quantity should not explode. It should not explode. And when I'm saying that it should not explode, what does it mean? Must be bounded actually. Must be bounded. So you can put it in some fraction of 3%. Okay, so this must be bounded. Okay, first of all, we say this has a limit. We say not so zero.
It exists.
As epsilon goes to 0. And the reading of having limit, so I can say that, so this ratio as function of epsilon must be bounded. It shouldn't explode. Must be bounded. And fall. Small enough epsilon. So this guy has derivative means that this limit should exist as epsilon goes to 0. If it exists, it should be some finite quantity. So you can put it in. Let me define some sets. Let me give it name A, K, N. Okay. The A, K, N is the collection of those omegas. So I want it to be bounded actually. This number to be bounded. Okay. So omega is a collection of the omegas such that this number of t plus epsilon minus w of t over epsilon is sitting between this fixed number here minus k prime. It's a collection of which minus. Okay. And it's depend on n, so it should have some description. And that this epsilon is a number between 0. So it's a collection of omegas for which this number is sitting between the interval minus k to k, and epsilon is the number that sits between 0 to 1. I can rewrite set.
The existential.
Existential, yes. I mean, if this exists, I mean, if this ratio is bounded, you can always find
K.
for every such epsilon, you can find such k. And obviously, if you have an epsilon, you can also find some number. So, if you have an epsilon, you can always find such number where it lies. You can also write this as write it bit level the square root of epsilon plus epsilon minus w of e over square root of epsilon plus k square root of epsilon and epsilon. Right. My claim is every such omega that satisfies this, for each such omega, you can find an n and k. You can find an n and k such that this omega is in the one of the sets. In other words, I would say that A is a subset of the union of k equal to 1 to infinity, n equal to 1 to infinity. K equal to union of n equal k equal to 1 to k. And 1 to infinity. K. What does this mean? So every omega that satisfies this condition, then you can find a k and you can find an n such that that omega is something inside satisfies this condition. Okay. When if it is bounded, you can find a number k such that it sits between them, and hence if you have a small enough epsilon, you can always find number 1. Okay? So what should be my next task? To show that this guy has a measure theory. That's what is my next objective. This guy must have a 0. I get rid of it. And this is a property precisely one of the reasons that, Brownian motion kind of becomes, a top choice to, though it's not a good choice, but it's a top choice of modeling things that are random. For example, in financial market. So it's a good model for all those randomness, where the randomness is occurring due to, what do you say, due to reasons. For example, in markets, you say that if you assume that prices are going up and down, okay, of anything, they go up and down due to two reasons, fundamental reasons, buy and sell. Okay? If there is a high demand, the price is going to go up. Okay, and if there is more supply, we're gonna so the buying and selling are two key things which kind of, but these are not the only things. That's what the key thing is. So therefore, the Brownian motion is not a good one. Okay, because it can accommodate with all such randomness when the things are happening due to factors. Take care. So what should I do next? Let's compute the probability measure of this K and K. Okay. Now, I want to compute the probability measure of this. The question is, how can I do it? So the question is, do I know, in order to compute the probabilities, you need to know the distribution of random variables. So which thing is a random variable in this? So this ratio is the random variable. Question is, what is the distribution of it? Wt epsilon minus Wt is going to have distribution by definition what? Normal distribution. With what parameter? 0 and t plus epsilon minus t. So it's going to be only epsilon. People get? And you are dividing it with the epsilon. So it's going to be what? So you have epsilon divided by, so something that is normally distributed with mean 0 and variance epsilon. Okay, and you are dividing that random variable by epsilon. So you are multiplying with epsilon. Okay. So if you wanted to find that if x is normally distributed with mean mu and sigma square, and you want to know the, for example, distribution of ax plus b, so it's for sure going to be normal distribution. But what would be its mean? So the mean is going to be a mu plus b, and what would be its variance? Its variance is going to be a square sigma square plus this. That's that. What do you think? What should be enough? So I have this w of t plus epsilon minus w of t over epsilon as normally distributed. That means this increment is normally distributed between u and epsilon, dividing it by epsilon. So the expectation of this is going to be still 0. The variance of it is going to be 1 over epsilon squared times epsilon. So it's going to be 1 over epsilon. Now I have a random variable, okay, whose distribution is this. This is something probability. Something x is normally distributed, with mu and sigma square, and x lies between two numbers a and b. And I want to compute its probabilities. Tell me what should I do? So you can integrate the PDF of x. That's one of the things. But you can also do is that take the CDF and evaluate at b and subtract the CDF evaluated here. Because this is the probability of x being less than or equal to b. This is the probability of x being less than or equal to b. What would be the probability of a and k now? So this k is going to be phi, okay, of k is square root of epsilon, okay, minus phi of minus k square root of epsilon. Just figure it out. This is going to be square root of epsilon or?
So if you're talking about variance 1 epsilon, because of both sides layer, it means we will have k minus k there.
K and
Minus k.
but
But not with epsilon.
okay.
So the epsilon,
Okay. So
talking about
this
this,
is talking about this.
the variance is now
Yeah. So it's going to be different.
1, the variance is 1 now.
We will have this one. Okay. So what other things know about this function phi? So do you know something interesting about function phi? So every CDF is continuous. This is continuous. And it's increasing as well. In other words, the more bigger number you involve, the more probabilities it's going to be, and the more area it's going to cover, and hence the more number difference. So you can say that this is less than or equal to phi of k over square root of n minus phi of minus k square root of n. Okay? It's square root of n because you know about the epsilon sum. Okay. Now what would be this? This is integral of something from minus infinity to k over square root of n, and the other is the integral from minus infinity to minus k over square root of n. Now I'm not writing all details. So this would be integral from where to where?
Minus k.
Minus k over square root of n to the k over square root of n. And what will happen if I take n goes to infinity?
0 to 0.
So this will go to the okay, because these bounds are going to really get near to each other. Okay. So the probability of n is okay. Moreover, what you can observe is that this sequence of sets A and K increases. Okay. So it's an increasing sequence. So it's increasing as n increases. Okay. As n increases. This is something that you can observe from the definition. So if this is the case, then I can say that A and K is contained in A n plus 1K. And hence their complements are going to be other way around. The other way. Okay. So I can say that omega minus K and K contains omega minus K and plus K. And now think about the probability of the unique and equal to 1 to infinity of K and K. So this would be same as, you can write this as probability of intersections. If I apply the De Morgan's, okay, so this is going to be omega minus, or I mean, if you want to write complement, you can write complement. We have to keep in head that you are taking complement from what perspective actually. Okay. So I can write this as the complement of this and its complement. So this is going to be the intersection I equal to 1 to infinity of A and K complements and their complement. Right. You say what? Index is? Yes, index. Okay. And I can compute this probability by computing 1 minus probability of intersection of n equal to 1 to infinity A and K. Okay. And what would be this probability? So it's a decreasing sequence, so we have a result. The continuity of the probability measure tells you that this is same as 1 minus limit n goes to infinity.
Probability of the limit.
Probability of A and K complement. A and K complement.
1 is 1.
Above roof.
So this is what?
So 1.
This is one part of proof. So
1 minus
everything is going to be
0.
okay. If this is 0, then you again take unions and take their probabilities would be 0, and A being contained in this union of union is also 0.
Sir, why can't we apply exam of probability measure? Probability of union is less than equal to some.
Try the other way. That's one way. Try that. Then it will tell you.
Yes.